When you create object-oriented software, you define classes that interact. Sometimes you have multiple classes that are related in some way. For example, in a video game you might have several classes that handle different functionalities for a player, like movement, combat, or dialogue. All of these functionalities are related to the player. A package groups together elements of your software that are related. These elements can be related based on data, classes, or user tasks, for example. A package also defines a namespace for the elements it contains. That is, a package is named and can organize the named elements of your software into a separate scope. An element can be uniquely identified in the system by a fully qualified name, based on its own name and the name of the package that the element is in. Package diagrams show packages and the dependencies between them. You can create one of these diagrams in order to organize your completed system into packages of related packageable elements. These elements might be data, classes, or even other packages. Package diagrams are helpful for when you want a high-level look at your system. They can help you see how a package contains related elements, and how different packages depend on each other. You'll see more in this lesson about what we can do with packages in package diagrams. A package has a simple depiction, which looks like a tabbed folder. If you do not have any elements that you want to show in your package, the package name goes within the folder, in the center. When details are needed, there are a few ways to show that a package contains elements. You can nest the elements within the folder just like this. Here, you can see the player package containing the movement interface. Alternatively, you can show a package containing an element using this notation. Again, the player package contains the movement interface. The contained elements in your package will be drawn below its folder in your diagram. This relationship is a composition, where the whole package has an element as a part. You can also list the contained elements in your package by their names. These names can be partially qualified, but should be unique within the package. Certain elements can be marked as public or private based on the plus and minus signs in front of their names. Public elements are accessible outside of the package by their fully qualified names. In this example, only the audio of the video game is available outside of it. You cannot access levels, accounts, and players outside the package. It is important to denote the relationships among different packages and elements appropriately. A package can import an element from another package. A package can import the entire contents of other packages, and packages can be merged. This diagram, for example, shows the level package importing location from the player package. This brings the name location into the level namespace, particularly for convenient use by elements in level. Also, the import tag says the import is public, so this name is visible for further import through level. The diagram also shows the level package importing data from the player package. However, the access tag says the import is private, so this name is visible only by elements within the level namespace and not further outside. This diagram is an example of how you would show a package importing another package. The user interface package is doing a public import of the player package, indicated by the import tag, essentially doing public imports of the visible names of elements in player. The user interface package is doing a private import of the buttons package, indicated by the access tag, essentially doing private imports of the visible names of elements in buttons. There is no need for the user interface namespace to make these names further known outside this namespace. This diagram shows how two packages are merged into one. Merging is typically done when you have two packages or concepts and you need them merged into a single one. This is a use of generalization that allows you to provide different definitions of the same concept. In video games, both vendors and quest givers are non-player characters that provide items, allowing us to merge the two into a non-player character package because of their similar functionalities, but slightly different definitions. Let's take a look at the big picture for a package diagram that uses all of the features I've talked about earlier. This diagram shows a complete package diagram for a simple video game system. It contains many packages that would definitely be found in a game. For example, there is a package for player, level, score, and analytics on player habits. These packages mostly interact with each other, meaning that they can publicly import each other. Analytics is different though, as it would typically require some communication with an online server to store data. This package is available by private import. The bonus level is special. It has a uses relationship with a normal level. The uses relationship implies that the bonus level requires a normal level for its full implementation. If there's no definition for level, then there can't be a definition for bonus level. A package diagram can be very useful in order to get a larger view of your system, particularly of namespaces and names, and who knows whom. It helps you to visualize the different namespaces and their purposes a lot more easily. You can get a good feel for how different groupings of classes interact. You can create a package diagram at any stage in development. They adapt and change with the latest version of your software. They are immensely helpful to technical designers to see the dependencies and relations between groups of related elements. Think of package diagrams as another technique in your repertoire for understanding and describing the system you're designing. When you show a system visually, it becomes a lot easier to spot flaws and inconsistencies.